Rationalizing the denominator. Our objectives. At the end of this presentation, you should be able to simplify radical expressions by rationalizing the denominator. Let's start. How to rationalize the denominator. Remember, a radical is in simplified form if all of the following are true. 1. There are factors in the radicand that can be written as a power greater than or equal to the index. That is, no perfect square factor should be under a square root sign, or no perfect cube factor should be inside the radical sign, and so on. 2. There are no fractions under the radical sign. And 3. There are no radicals in the denominator. The expression square root of 2 over 7 and square root of 3 over square root of 5 appear to be simplified. However, this expression violates the second and third condition. Our first expression, square root of 2 over 7, violated the second condition stated that there should be no fraction in the radicand. And the second expression, square root of 3 over square root of 5, is violated the third condition stated that there will be no denominator which is in the radical form. Thus, they are not considered simplified radical expressions. The process of rationalizing the denominator is used to simplify radicals of this form. Example. In rationalizing the denominator, consider the following rules. If x is greater than 0, y greater than 0, and z greater than 0. The first one is x over nth root of y is equal to x over the nth root of y times the nth root of y raised to n minus 1 over the nth root of y raised to n minus 1 is equal to x times the nth root of y raised to n minus 1 over y. Example number 1, square root of 2 over 3. So the first step is to distribute square root sign both on the numerator and denominator. So we can write this as square root of 2 over the square root of 3. After writing it, we can now multiply both sides, or the numerator and the denominator, by square root of 3 raised to n minus 1. Remember that your n is your index. Since in this given, the index is not visible, automatically your index is 2. So we can write this as the square root of 3 raised to 2 minus 1 over the square root of 3 raised to 2 minus 1. The next step is to simplify the square root of 3 raised to 2 minus 1. So we can have square root of 2 over square root of 3 multiplied by the square root of 3 over the square root of 3. As we subtract 2 minus 1, the difference is 1. Therefore, no need to write the exponent as 1. Now, we can multiply the numerator by numerator and the denominator by the denominator. We can combine square root of 2 and square root of 3 since they have both the same index. Remember, you can only do this if the index are the same. So since the index are the same, I will just simply write it square root of, then multiply 2 by 3. So we have 2 times 3 over the square root of 3 times 3. Multiplying 2 by 3 will give us a product of 6 over square root of 3 times 3, we have 9. Since there will be no factors of 6 wherein 1 is a perfect square number, therefore, the numerator is just square root of 6. Then, since 9 is a perfect square number and the square root of 9 is 3, therefore, our denominator becomes 3. So our answer is square root of 6 over 3. Remember, in rationalizing the denominator, our goal is to eliminate the radical in your denominator. Letter B, 5 over the fourth root of 2. So we can write this as 5 over the fourth root of 2 times the fourth root of 2. And since our index is 4, so we will write this as 4 minus 1. Remember, 1 here is constant. So that is over the fourth root of 2 raised to 4 minus 1. So let's simplify the fourth root of 2 raised to 4 minus 1. So we have 5 over the fourth root of 2 times the fourth root of, so we have 2, 4 minus 1 is 3. So that is the fourth root of 2 raised to 3. Then we can now multiply. Now since 1 is a whole number and 1 is a radical, so we'll just simply multiply them. So this will become 5 fourth root of 2 cubed over, and since the index of the denominator are the same, so we can combine them. So we have fourth root of 2 times 2 cubed. So write 5 fourth root of. So 2 cubed is 8. Simplify 2 cubed over, we have the fourth root of 2 raised to the fourth power. Since we have invisible 1 here as the exponent of 2, and since they have the same base, so we will just simply add the exponent. So this is equal by 5 fourth root of 8 over, so we can now cancel out the fourth root since this is 2 to the fourth power. What left is the base, which is 2. So the answer is 5 fourth root of 8 over 2. So for the last example, so we can actually combine 18x cubed y over the square root of 2x to the fourth y squared since our indexes are the same. So we can write this as square root of 18x cubed y over 2x to the fourth y squared, and then simplify. So we will divide this 2. So we have 18 divided by 2, we have 9. Okay, the square root of 9. Then, as we divide exponent, we subtract their exponent. So we have 4 minus 3, we have 1. So we will write 1 on the denominator since 4 is greater than 3. And same as y over y squared, I will write it as y on the denominator. So we can now simplify. So the square root of 9, so this is square root of 9 over the square root of xy. So the square root of 9 is actually 3 over the square root of xy. Now we can multiply both the numerator and denominator by square root of xy. So since again the index is 2, so we will just simply subtract 2 by 1, so the difference will be 1. So we will be having here as 3 square root of xy over, we have the square root of xy squared. So the square root of xy squared is simply xy, so we can write this as 3 square root of xy over xy. Example number 2. X over the nth root of y raised to m is equal to x over the nth root of y raised to m times the nth root of y raised to n minus m over the nth root of y raised to n minus m is equal to x times the nth root of y raised to n minus m over y. Letter A, 3 over the fifth root of 8. As you observe, 8 is a perfect cube number, because there will be a number which when you multiply 3 times by itself, the answer is 8. Therefore, we can rewrite that as its exponential form. So we can rewrite this as 3 over the fifth root of 2 cubed. After writing it, we can now proceed to the next step by multiplying both numerator and denominator by the fifth root of 2 raised to the index minus the exponent. So we can have fifth root of 2 raised to, so our index n is 5 minus 3 over the fifth root of 2, 5 minus 3. So let's simplify first. Fifth root of 2 raised to 5 minus 3. So we have 3 over the fifth root of 2 cubed times the fifth root of 2. 5 minus 3 is 2 over the fifth root of 2 squared. So we can now multiply 3 by the fifth root of 2 raised to 2. So we have 3 fifth root of 2 squared over, since the indexes are both 5, so we can actually combine 2 cubed and 2 to the second power. So we have the fifth root of 2 cubed times 2 squared. So we have simplify 2 squared, that is 4. So we have 3 fifth root of 4 over, so add the two exponents, so we have the fifth root of 2 to the fifth. So we can actually cancel out 5, okay, the exponent and the index. What left is 2. Therefore, our answer is 3 fifth root of 4 over 2. Next example, same formula will be applied. We have the cube root of 12x raised to 5, y raised to 8, over the cube root of 108, xy raised to 9. So since their indexes are the same, so we can actually combine them and simplify first. So we have the cube root of 12x to the 5th, y to the 8th, over 108x, y to the 9th. Simplifying, we divide 12 by 108 or simplify it. So we have 1 over, so we have the cube root of 1 over, so we have 9 because 108 divided by 12 is 9. Then we have 5 minus 1 as the exponent, so we have 4. So this is x to the 4th. So we have y to the 8 over y to the 9th power. So subtracting it, we have 1. So we will write y on the denominator since 9 is greater than 8. So this is now our new equation. So we will have the cube root of x to the 4th over the cube root of 9y. Now, 9 is actually a perfect square number. So we can actually write this into exponential form. So that is the cube root of x to the 4th over the cube root of 3 squared y. And then, after that, we can now multiply the numerator and the denominator by the cube root of 3 raised to 3 minus 1 and y raised to 3 minus 2. So we can write this as the cube root of 3. So the index is 3. So this is 3 minus 2 and y 3 minus 1. The next step is to simplify the given exponents. So we have the cube root of x to the 4th over the cube root of 3 squared y times the cube root of, so we have 3y squared. So we subtract 3 minus 2 is 1. 3 minus 1 is 2. So we have 3y squared. So we multiply the numerator by numerator and denominator by the denominator. So we can combine these two since their indexes are both the same. So we have the cube root of 3 x to the fourth y squared over the cube root of, so we have 3 squared y times 3y squared. So this is equal by, now take note, x to the fourth can still be simplified by dividing the exponent to the index, which is 3. So there are 1, 3 in a 4. So we can write x cube root of 3 and the remainder is 1. So we will just simply write x y squared over, so multiplying this is actually cube root of 3 cube y cube. Simplifying, we have x cube root of 3xy squared over 3y. In case of a binomial in the denominator involving square roots, use conjugates. The binomial, the quantity square root of y plus square root of x, and the quantity y, square root of y minus square root of x, are conjugate of each other, and the product of conjugate is the difference of the square of the terms. So x over the square root of y plus square root of z is equal to x over the square root of y plus square root of z times the square root of y minus square root of z over the square root of y minus square root of z is equal to x times the quantity square root of y minus square root of z over the quantity square root of y plus square root of z times the quantity square root of y minus square root of z is equal to x times the square root of y minus square root of z over y minus z. Example, 2 over 3 minus square root of 2. So we will just be getting the conjugate of 3 minus 2, which is 3 plus 2. So we can rewrite this as 2 over 3 minus square root of 2 times the conjugate, which is 3 plus square root of 2 over 3 plus square root of 2. Then we will just simply multiply the numerator by the numerator and denominator by the denominator. So we have 2 times 3 plus square root of 2 over 3 minus square root of 2 times 3 plus square root of 2. The next step is to distribute 2 1 by 1 by 3 and square root of 2. So we have 2 times 3 is 6 plus 2 times square root of 2 is 2 square root of 2 over, so we have 3 times 3, so we have 9. So you will just simply use the FOIL method. Okay, so we have 9, then we have plus 3 square root of 2 minus 3 square root of 2, okay, and then minus square root of 4. So let's analyze the denominator. So simplify. So this will be cancelled out. So what left is 6 plus square root of 2 square root of 2 over 9 minus square root of 4. So the square root of 4 is 2. So we can write this as 6 plus 2 square root of 2 over 9 minus 2. 9 minus 2 is 7. Therefore, our answer is 6 plus 2 square root of 2 over 7. Thank you.